Okay, let's talk about something called the ideal gas law. Okay, the ideal gas law. So the ideal gas law is a law that includes all four variables in one equation, and it also includes something called the molar gas constant. So the ideal gas law is PV equals nRT. So we know four of these five variables. We know P is pressure. We know V is volume. We know N is number of moles. R, we don't know what that is yet. And T is temperature. So in this ideal gas law, now we have this R. This term in our equation, R, stands for the molar gas constant. Sometimes it's called the ideal gas constant. So the molar gas constant R that we're going to use is 0.0821, and it has a unit of liters times atmospheres over moles times Kelvin. So there's four units in that ideal gas constant. It's 0.0821 liter atmospheres per mole Kelvin. That's R, the molar gas constant. You might see this R, this number extended out a little bit. Sometimes you see it as 0.0821 or 0.082059. It's extended into more digits sometime. This is going to be as extended as you need to use. The molar gas constant, just 0.0821 liter atmospheres per mole Kelvin. So when we're using the ideal gas law, we're using this molar gas constant. Because this molar gas constant has these four units in them, that means that each of these variables must have the same unit as the constant so that they'll cancel out in the end. So because pressure in the molar gas constant has a unit of atmospheres, that means pressure always has to be in atmospheres when we're doing the ideal gas law. Volume, because we have a unit of liters, volume must be in liters. Moles must be a number of moles. Temperature must be in Kelvin. So when you're using the ideal gas law, if you're given pressure in millimeters of mercury, you would need to convert it to atmospheres. If you're given volume in milliliters, you would need to convert it. If you were given something other than moles, like a number of grams or a volume even, you would need to convert it. And temperature, if it was given to you in Celsius or Fahrenheit, you would need to convert it. So let's look at a problem, an ideal gas law problem. So this says a 50.0 liter cylinder of nitrogen, again, don't forget those diatomic molecules, nitrogen is N2, has a pressure of 17.1 atmospheres at 23.0 degrees Celsius. What is the mass of nitrogen in this cylinder? So again, these problems are not going to be straightforward, and you might have to do a little bit of investigating to see how am I going to solve this problem with the information that was given. So this problem, if I were you and I was looking at this problem for the first time, I would read it and say, what information am I given? Well, here I'm given a volume. I'm given a volume that's 50.0 liters. Here I'm given a pressure that equals 17.1 atmospheres. Here I'm given a temperature that's 23.0 degrees Celsius. And what I'm asked for is mass. Well, I don't know any equations that use volume, pressure, and temperature to solve for mass. What I do have an equation for is to use volume, pressure, and temperature to solve for a number of moles. And then I could use the molar mass of nitrogen to go from moles of nitrogen to mass of nitrogen. So I'm going to solve for N, which is going to be moles of nitrogen, and then I'll use the molar mass of nitrogen to convert moles of nitrogen to grams of nitrogen. To do this, because I'm using the ideal gas law, I'm going to need to use R, which is 0.0821 liter atmospheres per mole Kelvin. This is the hard part of solving the problem. Figuring out what information that you have been given and making a plan to get to what the answer is. The math isn't hard. You're putting the numbers in the calculator. You're not doing any actual work to solve the calculation. This is what's hard. Reading a problem and saying, how am I going to solve for mass? And seeing the link between mass and moles, because you know that you can use the molar mass to go between mass and moles. Okay, so let's do this. So we have volume, pressure, temperature, and R, and we need to solve for N. So I'm going to rearrange this equation to solve for N. And I'm just going to do it up here. So if I have PV equals nRT and I want to solve for N, I'm going to divide both sides by RT. And then I have N equals PV over RT to solve for N. So I'm just going to plug my numbers in. N equals P, 17.1 atmospheres, times V, 50.0 liters, over R, 0.0821 liter atmospheres per mole Kelvin, times T, 23 degrees Celsius. We can't put this in the equation. Remember, we need to convert it to Kelvin. So I'm going to add 273, and I'm going to get 296 K. That's what goes in my equation, 296 K times 296 Kelvin. So when you do this, you're going to get a number of moles. N equals about 35.2 moles of nitrogen. This is not the answer to the question. The question didn't say solve the ideal gas law for N. The question said, what is the mass of nitrogen in the cylinder? Well, if I have 35.2 moles of nitrogen in the cylinder, I can use the molar mass of nitrogen to convert that to grams. Remember, nitrogen is diatomic, N2. So that means the molar mass of N2 is 28.02 grams per mole. This just comes from the periodic table. The molar mass of nitrogen, just one nitrogen, is 14.01, and I have two of them. So the molar mass of nitrogen, the gas, is 28.02 grams per mole. Anytime you see a unit that has 2 units in it, that should be a red flag that I can use that as a conversion factor. So I can use this molar mass to convert between moles and grams. So I'm going to start with the number of moles of N2 that I have, 35.2 moles of N2. The molar mass of N2, nitrogen, is that 1 mole of nitrogen has a mass of 28.02 grams. Moles of nitrogens will cancel, and now my answer is going to be left in grams, which is what I want because this question asked for mass in grams. And even though we don't have an equation to go directly to mass, we know that if we can solve for moles, we can use the molar mass to solve for grams. So when you do this with 3 significant figures, you should have something like 986 grams of nitrogen.